Hello everyone. Today, in 4i Coaching, we will be going through the topic of forces. This topic may seem easy to understand, but there are some questions which can be quite challenging, and we will go through those questions after a brief revision on the topic. So, what are the learning objectives? Firstly, we will learn what is considered a force, and the types it can be classified as. We will then learn about how forces affect motion, and how we can accurately calculate or predict the magnitude of the resultant forces, using Newton's first, second, and third law. So, what is a force? A force, by definition, is a push or pull on an object with mass that causes it to change its velocity. Quite simply, an action that causes something to move. Then what are the different types of forces? Well, there are countless different types of forces, which you can see from the image, including the tension force from the string, gravitational force from the mass of the cube, and magnetic force from the magnet. Since there are so many forces, we usually classify them into two groups, contact and non-contact forces. Can you figure out which forces in the image are contact or non-contact forces? Well, the tension force from the string is the only contact force, while the others are not contact forces. So, how does forces affect motion? Well, in reality, an object hardly has only one force acting on it. Instead, multiple forces are acting on it constantly. This forms a single force that controls the movement of the object, known as the resultant force, obtained by combining a system of forces acting on the same body. Looking at the picture, we see a cart getting pulled by a 60 Newton and 30 Newton force to the right. This will add up to form a 90 Newton resultant force to the right. The second cart, on the other hand, has a 10 Newton force acting to the left and a 30 Newton force acting to the right. Thus, if we add up the forces, we can see that the resultant force for the second cart is 20 newtons to the right. Newton's first law. Newton's first law states that if the resultant force acting on an object is zero, we say the forces acting on the object are balanced. Though an object is balanced, it does not mean that the object stops moving entirely. There are two cases. Firstly, for an already stationary object, the object will remain at rest until there is a net force for it to move. While for an object in motion, it will continue to move in the same direction with constant speed. This can be seen in football, where the ball will obey these laws until affected by an external force, creating a net force in a certain direction. Newton's second law. Newton's second law states that when a resultant force acts on an object of a constant mass, the object will accelerate in the direction of the resultant force. The product of the mass and acceleration of the object gives us the resultant force. In layman's terms, Newton's second law allows us to calculate the magnitude of the resultant force of an unbalanced object, and we can do so by calculating the object's mass and acceleration, using the formula F net equals ma. Newton's third law. Newton's third law states that for every action in nature, there is an equal and opposite reaction. This means that if body A exerts a force on body B will exert a force back to body A, which is equal in magnitude and different in direction. Now that we have gone through the basics of forces, we will go through some examples of exam questions. Firstly, we have the vector diagram question. There are two forces, F1 and F2, pointing at different sides, and we can roughly estimate that the resultant force will be outwards at a slight angle using common sense. We can then confirm this by drawing the lines F1 and F2 again at opposite sides to form a parallelogram and connect the edges to form the resultant force. When drawing this, it's important to ensure that the angles at alternate angles are the same. If you want to calculate the actual length, we can draw a diagram out on a piece of paper and let the scale be 10 meters equals 1 cm, or whatever you find suitable. By drawing out the parallelogram, we are able to measure the length of the resultant force and thus calculate the exact magnitude of the resultant force. For question 2, we can see that there is a truck pulling a trailer. As we move forward, it faces resistance from friction. In these types of questions, it is always better to draw a free body diagram first, even if the question does not ask for it, as it will help you to visualize the situation better. Since there are two separate objects, we draw two different free body diagrams and highlighting the forces present in them. By doing so, we are able to see how the object is affected by the forces. To calculate the tension of the tow bar between the engine and the trailer, we can use the formula F net equals ma from Newton's second law. In this case, the trailer is only affected by two forces, the tension force of the tow bar and the resistance force it faces. Yet, it moves forward, showing that the tension force is of higher magnitude than the resistance force. Therefore, we can write the equation as T minus RT equals ma. And we are able to substitute the given information for the question to answer and find tension. To calculate the forward thrust, we just have to use the free body diagram of the truck and do the same thing that we did for the trailer. Identify the forces and submit the given values. If done correctly, it should look like this. Question 3 has always been a killer question in exams, since most students don't know how to start with so many different elements and forces coming into play for this question. Yet, in reality, this question is really simple. Firstly, like all questions, we split the individual components and draw out their free body diagrams and label their forces. In this case, you can ignore the gravitational and normal force since they cancel each other out due to Newton's third law. From here onwards, we are able to make three equations using F net equals ma. Then, we can add these equations to form a new equation. By adding T2 by adding equation 1 to equation 2 and equation 3, we will be able to get a new equation Fa equals m1 plus m2 plus m3 times acceleration. And by subbing in the given value of Fa equals 300 meters, we are able to get our acceleration, which is 20 ms per second. Then, like the other few examples, we sub in the acceleration into our individual equations to find the tension forces. You should be able to get an answer of 260 meters for T1 and 100 meters for T2. If not, try to find out your mistake on your own or by referring back to the earlier videos. We have come to the end of our presentation. We hope that you have learned something from this video, and do leave your questions in the comment section if you need any more help. Lastly, always ensure that you draw free body diagrams even if the question doesn't ask for it. It is very useful, especially if you are struggling to solve the question. Furthermore, forces is not a topic you can ace by just visualizing notes. Do make sure to do more practices on your resource book to learn the different types of questions that they can ask. And always remember that no matter how intimidating the question can be, always remember the basics, and you will be able to solve it with no problem. Once again, thank you for listening to 4i Poetry. Do hit the subscribe button if you want more content like this. Thank you.